Hola a todos, soy Javier Poveda y esto es De Bien TV, el canal en el que te lo vas a pasar de bien mientras aprendes geografía, historia e historia del arte. El vídeo de hoy va dirigido a mis alumnos de primero de la ESO de sección del IES Neil Armstrong de Valdemoro. Antes de empezar, como siempre, quiero desearos a todos que estéis lo mejor posible de salud, así como vuestras familias. So, in today's video, we are going to correct the activities of the exam preparation of units 3, 4, and the first part of the unit 5, which is this document here, which I sent you several days before by email. So you will have it close to you here because we are going to correct all the exercises with a presentation I have made for the occasion. So let's start with it. Okay, so we are here. We are going to correct this exam preparation, and the first question was the definition, or is the definitions. You have to define the following terms in your own words. So I have done it with my own words, the words that I wrote in the presentations, but you have to know that it is not necessary to write exactly the same thing that I wrote here, okay? You can also define these terms with your words in a correct way, and it is not necessary to be the same, identical as it is here in this presentation, okay? So let's start with the hydrosphere. The hydrosphere is the set of all the water in the oceans, seas, rivers, lakes, polar ice caps, and glaciers, as well as the groundwater and the water vapor in the atmosphere. For each of the definitions, I have also pointed where what the solution is located in the textbook. Okay, for example, the hydrosphere, you can find the definition on page 42. They are also in the presentations of the units I gave to you, but for it being easy, for it to be easier, I mean, to find it, I have written the pages of the book. The tides are the rising and falling of the sea levels. Then they are caused by the gravitational forces of the moon. You can find it on page 44. Remember that in a definition you have to write what it is and later their characteristics, okay? Like where is it, or what it is used for, or the main features, okay? But you have to write always in a definition what it is at first. The flow is the amount of water that a river carries. You can find it on page 46. The cryosphere is all the ice in the world. Most of it is in polar ice caps and the rest is in glaciers on high mountains. So the cryosphere is a part of the hydrosphere. You can find it on page 46. Then the atmosphere is a 1,000 kilometer thick layer of gases covering the Earth's surface. The atmosphere's two main components are nitrogen and oxygen. Okay, there are other gases such as argon or I will say it, carbon dioxide or water vapor, but the main ones, the two main gases of the atmosphere are nitrogen and oxygen. It is on page 60. The stratosphere is one of the many layers of the atmosphere. It is located between 12 and 50 kilometers above the Earth, and in this layer the ozone layer is located. Okay, the ozone layer is located within the stratosphere, which protect us from the ultraviolet rays that come from the sun, and it is on page 61. So let's start with the second half of the definitions. The hygrometer is an instrument which is used to measure the air humidity. Okay, it is on page 64. The atmospheric pressure is the force of the air on the surface of the ground. It depends on altitude, on the air temperature, and on powerful air currents, which we know as jet streams. Okay, as you know, the force of the atmospheric pressure at sea level, the average atmospheric pressure is 1015 hectopascals or millibars. You can find this on page 66. The insolation is the amount of solar energy that reaches a location, and it affects the temperature of the place. You can find it on page 78. The isoheat the isoheats are imaginary lines in a map that connect places or points on the Earth's surface. Surface should be without this capital letter, that's a typo, with the same amount of rainfall. Okay, you can find it on page 81. So the points that are covered or where the isoheat goes through have the same rainfall, the same amount of rainfall. The isobar or the isobars are the same as the isoheats, but with atmospheric pressure. So they are imaginary lines in a map that connect areas or points on Earth with the same atmospheric pressure. Okay, remember that the atmospheric pressure is measured in millibars. You have it on page 7. And finally, a climate graph is a graph that shows the average temperatures and monthly precipitation for a place in a year and allows us to identify the type of climate. You have this on page 90, and we will do some of them on the activity 4 of this exam preparation. So that's all for the definitions. Now we go to the second question, or the second activity, which are the short questions. Now a little rest for coffee. Okay, so what is the difference between weather and climate? The weather is the state of the atmosphere at a particular or at a specific place and time. You have it on page 59. The climate is a succession of weather conditions of types of weather in an area over a long period. You have it on page 77. For example, the weather right now, today is April the 1st, and right now in Rivas, where I live, I am looking through the window and I can see we have bad weather. The sky is totally covered by clouds. It is cloudy and it is going to rain in a short time. So that's the weather. That's the state of the atmosphere right now at this moment I told you. And the climate is the succession of weather conditions. For example, this type of weather, as cloudy and rainy, it is usual in the seasons of spring and autumn in the area of Madrid. Why? Because in Madrid we have a Mediterranean continental climate, so it means that the usual weather at this period of the year, for example, is cloudy and rainy. But for example, if we were in August, it would be summer, and the temperatures, the usual weather conditions in August are sunny sky and high temperatures. This happens every year. It repeats every year. Why? Because the climate is the same. So that's the succession of weather conditions over a long period. Because the climate, I mean, is cycle. Okay, it's a cycle of weather conditions. The next short question is, what are the ocean currents? What types do you know? Pardon. What types do you know? Name one of each type. The ocean currents are like big rivers moving within the oceans. Okay, they're big masses of water with the same conditions of temperature, and they travel through the ocean. The currents there are several types, but the most important ones are the warm currents and the cold currents. You have it on page 44. And then you have to name one of each type. To do this, you have to look at a ocean currents map. I think there's one on the book, but I wasn't able to find it. But I think one student showed me one in the book some time ago, but I couldn't find it on the book. So you can use the one I showed you in the presentation of the unit 4, okay? Or you could look at it at the internet. So if we look at a map of the ocean currents, we have to choose one warm current. I have chosen the Kuroshio current, which is in Asia, and an example of warm current. This is a typo, so it's not a war current. We are not fighting the ocean. Of warm current with an M at the end here of warm current is the California current, okay, which is in the Pacific Ocean. You can find this in the Unit 4 presentation in this slide 7. Then the third one, name the uses of fresh water and seawater. You just have to name them. You don't have to explain them. The uses of seawater are food as an energy source, as waterways for transporting goods, tourism as an economic source, and for drinking water with the desalination plants. You have it on page 45. Then the uses of fresh water are for agriculture, as urban underground deposits, for leisure, for fun, for reservoirs, because sorry, because I should have coughed in my elbow. The reservoirs, because which use the water, the water falling to produce electricity, so as an energy source, and for reserve in aquifers and wells for human consumption. You have it on page 47. The fourth one is why do precipitations occur? Sorry. Why do precipitations occur? Name the different types of precipitation. So this I wrote here the long answer, but you can also answer this in a shorter way, okay? But I prefer this. So water vapor cools at high altitudes and it condenses into droplets that accumulate and form clouds. If they cool down a lot, they change into ice crystals, and if the air continues to rise or the temperature cools, new droplets join those already in the clouds. These new droplets are bigger and heavier, so they fall as rain. When the temperature in the layers of air is very low, the ice crystals in the clouds do not melt when they fall. They do not turn into liquid. So instead, they join together and form snowflakes. And finally, the hail is formed when ice crystals in the clouds are pushed upwards by ascending air currents, and the crystals grow bigger until they are heavy and fall. You have this on page 64, and these are the three main types of precipitation and how they occur, okay? Then the main types of precipitation, therefore, are rain, fog, snow, dew, frost, and hail. You have it on page 65. The E short question, the fifth one, is why does temperature drop with altitude? Calculate the temperature of a location at an altitude of 2,500 meters, providing that the temperature at sea level is 25 degrees centigrade. So the reason why temperature drops with altitude is that because the air closest to the Earth's surface again without the capital letter, is warmer. The temperature drops the higher we go because the air is less dense and does not retain heat. The average reduction of temperature is around 6.4 degrees centigrade for every 1,000 meters of altitude. So for every 1,000 meters of altitude we go, the temperature will drop 6.5 degrees centigrade. Therefore, because of this, the temperature of 2,500 meters of altitude, it is 16 degrees centigrade less than at sea level. Why? Because we have to divide the height, 2,500, we have to divide it by 1,000, and the value is 2.5. This means that the temperature at this height is going to be 2.5 less, or the decrease is going to be 2.5 degrees for every 1,000 meters. So if we know that the reduction of temperature is 6.5 degrees for every 1,000 meters, for 2,500 meters is going to be 6.4 multiplied by 2.5. So the value is 16. Therefore, if the temperature at sea level is 25 degrees centigrade, the temperature at 2,500 meters is going to be 25 minus 16, which is 9 degrees centigrade. You can find this on page 78. And the last short question is, what are the climates of the Iberian Peninsula? What is the climate of Valdemoro and Tenerife and Galicia? So the climates of the Iberian Peninsula are these 5 ones, which are Oceanic or Atlantic, the green one, Mediterranean, the orange one, the Mediterranean continental, the yellow one, the mountain, which is the purple one, and the subtropical, which is the brown one. You can find this on pages 84 and 85. And now to find out what is the climate of a specific location, you have to look at a map. So Valdemoro, where is it? It is here more or less where I am pointing with the mouse, and this climate is Mediterranean continental. Tenerife, which is this island of the Canary Island, its climate, we can see the brown color, so it is a subtropical climate. And finally, Galicia, which is this region here on the northwest of Spain, of the Iberian Peninsula, the climate is Atlantic or Oceanic. Okay, here you have. And this is all for the short questions. Then the third one is the weather maps. You have to, I want to read it, you have to look at those weather maps and answer these questions. What will the weather be like in the Iberian Peninsula? Which direction will the wind blow? Will it be intense or weak? So, to do this, we have to first look at the pressures. Okay, so here we have an anticyclone here, which means here we have high pressures, and here we have a depression, which means we're going to find low pressures. So we are interested in the Iberian Peninsula here, and we have to take a look at the isobars, and we can see that here this one is 1008, 1012, 1016, 1020 and 1024. So we know that if an isobar if the pressure is below 1015 millibars, it means low pressures, and if the pressure is above 1015, it is that we have high pressures. So we can see that we have low pressures in the western part or western half, more or less, of the Iberian Peninsula, and we have high pressures in the other part, in the eastern part. This means that we should expect bad weather in this part where the low pressures are, and a high chance of precipitation in these areas. On the other hand, we have that in this area, in the other half of the peninsula, we have high pressures, so we will have better weather, good weather, stable weather, and a low chance or low probability of precipitations. Then to find out where the wind is going to blow, or where it comes from, we have to know that the wind blows from the higher pressure areas to the lower pressure areas, because the nature or the physics tend to even the pressure conditions. Okay, so the wind will blow from the higher pressure areas to the lower pressure areas. Therefore, we know that the higher pressure areas are in this part of the map, and the low pressure areas are in this part. So the wind will blow from the north or the east, from the northeast of the Iberian Peninsula, and it will go towards the southwest or the west of the peninsula. The wind will be more intense here in this area, in the western part, because the isobars are closest to each other. Okay, are very close to each other, and it will be weaker here in this area because the isobars are located much farther away. And that's it for the first map. The second weather map, here we have to take a look. We have to do the same procedure as in the previous one. So we look at the Iberian Peninsula, and we can see that this anticyclone is very dominant in in most of the Iberian Peninsula, and we have a depression here on the north of Africa, which affects the southern part of the Iberian Peninsula. So then we have the isobars. Here we have an isobar with a value of 1024. That means that we are going to have stable weather, good weather in almost all the Iberian Peninsula, okay? We don't have the value of this isobar, but we can know that it is higher than this value because it is closer to the center of the anticyclone. So all of this, or most of the Iberian Peninsula, is enjoying good weather. And the only part in which we have a chance of precipitation or bad weather conditions is the southern part of the Iberian Peninsula, this the southern east part, because of the influence of this depression here. So the wind will blow from the areas with higher pressure to the areas with lower pressure. So it will blow from the north or from the northeast to the south, okay? And the intensity will be low intensity, will be weak, the force of the wind, because the isobars are not very close to each other, except for this little area here in Catalonia, in which the wind may blow a bit stronger, okay? So that's it for the weather maps. And then we have the fourth question, which is the climate graphs. In this activity, you have to, and I'm going to read, create the climate graphs corresponding to each of these tables, of the 4 tables A, B, C, and D that I wrote here. Okay. You have the instructions below the tables, and you have to follow the steps given in the presentation of the Unit 5, and I also recorded a video drawing my own climate graph in my blackboard. Well, it's a whiteboard actually. And then you must answer these questions. What is the average annual temperature? Is it called tropical or temperate zone? And what is the annual total rainfall? It is a very wet, dry, or arid area. You have to answer these questions for every and each of the climate graphs. So you have to answer this question for climate graph A, for the B, for the C, and for the D1, okay? For each one of them. So I'm saying this because many of you at first didn't do this, so this is a reminder. So the climate graph A, the first one, should look more or less like this one I have drawn here with PowerPoint, okay? The average annual temperature is 14.4 degrees centigrade. The annual total rainfall is 1,154 millimeters, and so therefore the climate is a temperate climate and a very wet climate, okay? And I have also drawn this with my computer in an Excel spreadsheet, and this is the shape how it will look like in a different scale of the graph, okay? These two graphs are the same but at a different scale, okay? But the values are unique, so they should be like this, okay? So for the climate graph B, the second one, we have this shape. The important thing here is that in August it didn't rain, so you have to draw no precipitation bar. The average annual temperature is 16.4 degrees centigrade. The annual total rainfall is 480 millimeters, so it's a temperate and dry climate. And this is how it looks like, and this is also how it looks like. Okay? That is it. You can pause the video whenever you want if you want to take a look, a closer look. So the climate graph C, the third one, is it looks like this, and the particular thing of this climate graph is that it has negative temperatures in the winter months, in December, January, and February. So you have to draw the red line here below the precipitation bars in these months. So the average annual temperature is 7.7 degrees centigrade. The annual total rainfall is 562 millimeters, and it is a temperate and wet climate. Okay, and this is how it looks like in Excel. Okay, this is the reason why I told you that you should write the 0 not at the very end of the horizontal axis, but a bit higher, in order to be able to write or to draw the precipitation, the temperature line, when it happens to when we have, I mean, negative temperatures or below 0 temperatures. Finally, the climate graph D, the fourth one, it looks like this. It's a very rainy climate, and the average annual temperature is 15 degrees centigrade. The annual total rainfall is 1,492 millimeters, and it is a temperate and very wet climate. Okay, and it looks like this. And that's it. This is all for the okay, let's change the camera here. Okay, so this is all about this exam preparation. I hope it was useful for you in order to understand all the content of these lessons. Así que, como os acabo de decir, espero que os haya sido de ayuda, y cualquier duda, como sabéis, podéis preguntarme cuando queráis, en mi correo didascadosjavi@gmail.com. Muchas gracias por ver el vídeo y nos vemos en el próximo.